Good day everyone, I am Stephanie Graceton, and in this video I'll show you on how to apply one sample test, chi-square test, and binomial test in educational research. First, let's go to one sample test. In the population, the average IQ is 100. A team of scientists wants to test a new medication to see if it has either a positive or negative effect on intelligence or no effect at all. A sample of 30 participants who have taken the medication has a mean of 140 with a standard deviation of 20. Did the medication affect intelligence? We're going to answer the question using the 7 steps with an alpha level of 0.05. Notice that we don't know the population standard deviation. We only know that the population mean is 100. We do, however, know that sample standard deviation, which in this case is 20. That's why we're doing a t-test instead of a z-test. So step 1 is for us to define our null and alternative hypothesis. Then we will state the alpha, calculate the degrees of freedom. Because this is a t-test, then state the decision rule, calculate the test statistic, state the results, and state the conclusion. Let's get started with the first step. We're going to define our hypothesis. In this case, null hypothesis is that the mean is equal to 100 because in the population, the average IQ is 100. So that's what we would expect the mean of this sample. Next is our alternative hypothesis is that the mean is not equal to 100 because we're testing to see if it's any difference from the expected value of 100. Next, the alpha level is just 0.05 because I said use 0.05. Now we're going to calculate the degrees of freedom. Now connecting the degrees of freedom from a t-test is like this. It's just n minus 1, something as it was before. We have 30 participants minus 1 is 29. So this t-test has 29 degrees of freedom. This has an effect on what credit value we use, which is going to be coming up in just a bit. Step 4 is to state the decision rule. Now we have an alpha of 0.05, so we want to find the middle 95% of where we would expect to the mean to be. If it's outside of that in this two-tailed test, we're going to conclude that the mean we have is strange and likely is different from the population we're comparing it. So using the t-table, the critical value we're going to use is 2.0452. That's what I found using the alpha level and the degrees of freedom for the t-test. So what is our critical value? So we would expect most values we calculate to fall with a negative 2.0452 and positive 2.0452. For if it falls outside of the range, we're going to conclude that our sample is different from the expected population. So now our decision rule is if t is less than negative 2.0452 or greater than 2.0452, reject the null hypothesis. So now let's actually calculate the t, and it uses the equation right here, where the sample mean is 140, the population mean is 100, the sample standard deviation is 20, and the sample size is 30. So I'm just going to plug those things in the equation, and that's how I get a t of 10.96. Next step is for us to state our result. Now remember, our decision rule was if the t was less than negative 2.0452 or greater than positive 2.0452, we're going to reject the null hypothesis, and we found a t of 10.96. 10.96 is greater than 2.0452, so we're going to reject HO. We're going to reject the null hypothesis. Now our conclusion, or what is this mean, is that medication significantly affect intelligence basically and did something to change it from the expected value of. In the case, it was 140, so it looks like it went up a lot. We can't really say that, but it is different from the 100 we thought it would be, and I have t equals 10.96 with p less than 0.05. Next, let's proceed to chi-square test. 500 elementary school boys and girls are asked which is their favorite color. blue, green, or pink. We have the results now using an alpha level of 0.05, where we conclude that there is a relationship between gender and favorite color. So here is our table. In the bottom, you can see that I have the columns totals 120, 180, and 200. And on the right side, I have the row totals 300 and 200. And we had a total sample of 500 people. So we can use this information to calculate our chi-square. We're going to do a hypothesis test using those same 7 steps that we always do so. Step 1 is for us to state our null and alternative hypothesis. Our null is that for the population of elementary school students, gender and favorite color are not related, while our alternative hypothesis is that for the population of elementary school students, gender and favorite color are related. Now alpha, like I said, is always 0.05. Now calculating the degrees of freedom, we're going to take rows minus 1 times columns minus 1. It's 3 minus 1 times 2 minus 1, or 1 times 2, which is 2. This analysis will use 2 degrees of freedom, and that's how we'll find our decision rule. Using a chi-square table and using alpha 0.05 and 2 degrees of freedom, I find a critical value of 5.99147. So our decision rule is, if the calculated chi-square is greater than 5.99, we are going to end up rejecting the null hypothesis. So let's calculate our chi-square now. Now we're going to use the same equation to calculate chi-square, except now it's going to be a little bit more complicated. To find the expected frequencies for the columns times the frequency for the rows, and then divide by the total number of subjects to get the expected frequency for each cell. For example, let's say we wanted to find how many boys are expected to have chosen blue as their favorite color. We take the column total for blue, which is 120, multiply it by the row total for boys, which is 300, and we divide by the total number of subjects, which is 72. And we find out that this is sample. We would have expected 72 boys to choose blue as their favorite color. And then we can continue that to get the expected value for all 6 cells. So now I'm just going to move that up, and we have the observed values and the next to them in parentheses. We have the expected values, and now we're going to do chi-squared like we did it before. We're going to take all the observed value and subtract the expected value, then square that and divide by the expected values to get those 6 different fractions. Where we add those all together, we find a chi-square of 276.389. So our result is, because our chi-square is greater than 5.99, it was 276.389. We will reject the null hypothesis. That is to say that in the population, there is a relationship between gender and favorite color, using the chi-square test for test of independence. Next is, let's proceed to binomial test. But in binomial test, I'll be just giving you a link to watch for us to be able to fully understand what is binomial test. Just click the link and watch the video. So thank you for watching this video. I hope that you will be able to learn how to apply one sample test, chi-square test, and binomial test in educational research. Thank you again.